My name is Ole Klifoth. I founded Audiovector in 1979. And I did that because I fell in love with the direct live sound of the jazz clubs of Copenhagen. And I thought that if you could get that sound at home, sitting 4 meters from a saxophone or from a drum kit, which wasn't amplified, to get that real sound, that real live sound. This was my goal, was my dream, this is what I wanted to do. So at that time I worked in a hi-fi shop where we had really good loudspeakers from, Quad or Celestion, JBL, KEF, and many others. And all of them could do some of the things that I could hear in the jazz club or in the Tivoli concert hall, but none of them could give me the whole sensation. And this is what led me to think, probably because I was young and naive, I'll do that. And this became my project. And I can say, spooling forward to now, that we've moved so many curtains between the music and the listener. And it's still the product. I mean, in 10 years, I'll probably, if I'm not dead, say the same. I'll say, this is still my dream. But this one gets very, very close. If we should talk about the technical background of this, the technical background is that I found out that with the most dynamic speakers, you had coloration, but you had no delay, you had a willingness to just play. And with most neutral speakers, you had some delay, and I found out that if I could remove compression, at Audiovector we have a principle called low compression concept, LCC. And this concept covers everything from the way we design the cabinets, the way we think about the dampening inside the cabinets, or the lack of, the way we think about the crossovers, one component in series with each driver, no more. The way we think about decoupling. We have plinths here and we decouple to the floor. We don't use any rubber or any isolation between the speaker and the floor, because then we destroy the stream of vibration that we want to route away from the loudspeaker, drain away. And it has a lot to do with the drive units. And now that we're looking at the R10 here, these are brand new drive units, which I engineered to be better at acceleration. The acceleration for the first few millimeters, if you can get that loosened up so it has less restraint there, then when it starts to moving, it's a different case. But just to get it going for the first watt or half watt or so, improves the detailing of it enormously. And if you can imagine that you have, say, it's a big orchestra, classical orchestra, and something is going on 30 meters down into the background where somebody is standing there with a triangle and so on, you want to hear that too while all the others are playing. And this becomes easier with this accelerated concept that we have here. So they move really well, they move fast, and they have a special surround here, the corrugated surround, which makes them be more articulate in the higher frequencies. And this has to do with the way it meets the treble drivers. These treble drivers are really fast, as you know. So this is a very good combination. But it's all got to do with low compression. Low compression is also using cabinets which are teardrop shaped and which have absolutely no standing waves inside. This means that there's almost no dampening material in a speaker like this. And the way dampening material works is that it absorbs sound and converts it to heat, which means you lose energy inside the cabinet, and that energy you don't get out as dynamics or sound for you. So this is why it's a really, really good shape, this teardrop shape. Done away with the standing waves totally in this series, which is a good point. The other point is that we have titanium voice coils. And a titanium voice, when the voice coil is wound on a titanium former, it has less hysteresis or less delay, less distortion. It reacts quicker, so the titanium technology is present everywhere in the R series, everywhere. Okay, let's just take a walk over here then. So you see, here I have a magnet with a copper cap. This is just to remove distortion. Here I have 2 different voice coils, and when I drop this voice coil, for example, down into the gap here, you saw the delayed movement. This is a copper coil wound on aluminium, and everybody uses aluminium. I don't know why they like it so much. This one is wound on a titanium former. No delay, no resistance, right? This is just one small important thing, and one little part of the low compression concept thinking that we've been using for many, many years. So everything. Now, if we talk about the crossover of a speaker like this, of course we use premium components. And premium components means that we have listened to them. We've listened to the capacitors, for example. You can get really expensive capacitors which sound too dry or too live, maybe, or too resonant. We've developed our own capacitors for this one and for other speakers, which have, for us, the exact balance between the dryness and the live energy. So, and this is a copper foil with tin dust flashed on it and polypropylene, and all the things you can say about this. Who knows what these things mean, but we've listened to them and we've compared them to 500 other types, and we know what we want. So we have had somebody make these capacitors for us. And also for the tweeters, we just added and this is for real safety, a dual-on capacitor, a paper and oil dual-on capacitor, just as a bypass, so at 200. Nobody can hear that. What you can hear is that with these air motion transformers, which go up to 53 kilohertz, and we can't hear 53 kilohertz, but we can hear what is going on from, say, 20,000 and downwards. And if everything's okay in the hearing range, and you move all the artifacts and the problems way out of the hearing range, all the phase problems that arise when a driver rolls off, if all that is moved away from the musical spectrum we listen to, then you get a clearer, a faster, and more precise sound. So, and this is, the same thinking all the way through. We don't want anything to limit our drivers. The cabinet can't limit it, the crossover can't limit it, the AMT drivers, which are open backy AMT drivers, they're open to the rear here, just like the original Oscar Heil construction. It was never intended to be a closed construction. I know most AMTs are, but these are open back AMTs, and they're much faster and much lower in distortion. So this is these are some of the things that have gone into this. Inside, how it's braced and how we get a really, dead sound, and how we don't get a sound which is too dead, because you still need the music to be open, and it needs to be easy to listen to. Not only when you take your favorite audiophile recording, of course this has to sound perfect, but with many other recordings. And I think the general idea has always been that we make speakers for music lovers. So if you, for example, have a special band you love, and maybe it's not the best recording in the world, you should be able to play it and enjoy it on a pair of Audiovector speakers. You shouldn't shy away from those and only play the 10 best recordings you have. This is for music, made for music. you could say. About the materials for a speaker like this. This one has a wonderful, it's a walnut burl, it's a root. It's from the walnut root. Material is made from 10 layers of or 2mm HDF, and HDF is the heaviest and the densest type of MDF, HDF there is. This one is made from maple and oak, and it has been vibrated, high frequency vibrated, to have to be very, very dense. No loose core of the material, very dense. Then they glue that together. They have a big aluminium form which is heated, and then they press the shells onto a certain level, a little more than is necessary, because these guys are so clever that they can calculate the spring back of the rounded side of the cabinet. So when they take two shells and they take the top here, and it's all cut 45 degrees, they fit together. And I'm really impressed. We're not doing it, but we have some artisans doing it. I'm really impressed how they can, how precisely they can predict what is going on and make it correct every time. If you look at the finish of the cabinet, the edges, they are slightly rounded. They're very soft, and this is hand veneered, and we have 11 layers of clear lacquer with sanding and polishing and so on in between to get this finish. It's not the world's cheapest finish, but it looks really good, I think. So we're talking about a high quality product, and very often you will see a product like this shown with the very best, the very most expensive amplifiers. And there are some really good ones out there. But you can drive it with a 2x4 watt tube amplifier too, if you want. Not extremely loud or anything, but you know, it's still possible because it's quite efficient. The impedance curve is not nasty because we don't have nasty crossovers. I told you that before. And we don't need nasty crossovers because we engineer the drivers ourselves. We know how the curve looks and how the roll-off is. We know everything. That's engineered into the drivers. And that holistic engineering, where we start with the drivers and the cabinets, pays off in the form of less problems with crossovers, less problems with phase angles and so on. So that's the way it works, and as you've heard in there, they're not too bad.